All right, so whenever in Java, whenever you're dealing with doubles and floats, you're doing math on them. Actually, all computers really. What's actually happening is you're going from base 10 decimal to binary to perform the math, and then it's being converted from binary back to decimal. So some of the accuracy will be off. That's why sometimes, I don't know if you guys noticed, but like for this particular problem, there's cases where it will tell you that you only have, 3 pennies when you really have 4, or two pennies when you only have 3, because really the number is like 2.9999997. There's actually like an IEEE standard of how accurate doubles and floats are supposed to be. So if you just Google that, like IEEE, I don't know if you care this much, standards for doubles. Yeah, there it is. IEEE standard 754 for double precision. If you want to read about it, you can, but basically the idea is whenever you're converting from decimal to binary, like the computer is doing it, like it's going to lose some accuracy, right? Like very, very little. That's why we end up with, instead of like a number like 3, we'll end up with 2.9999999, and it's okay. I don't expect you guys to solve those problems, but I know like it might be kind of annoying for you to see that. So I'm going to show you a couple of things that you can do if you're running into those problems. But if you did want like your decimals to be more precise, Java does provide a class called Big Decimal, which does more precise decimal numbers where you won't have those types of problems. But anyways, I'm going to go ahead and demonstrate this example here. So if I compile and run this program, okay, and I'll enter the number that the book has, which is what, 4673 or something like that?
Yeah, I think so, yeah.
46. So the book has you enter $46.73. You get 4 ones, 1 5, 1 ones, 2 quarters, 2 dimes, 0 nickels, and 2 pennies. You should have gotten 3 pennies, right? If I were actually to print out the remainder right here, like here's a leftover. If I would have printed out, let's see, leftover. Yeah. So you don't actually have to do this part right here, really. No, we could have. Did you have to do that? I mean, like, you don't need, like, we don't really need to do that equation right there.
That one?
Yeah. It's not necessary. But anyways, I'm going to go ahead and print out whatever's the remainder, like, right before we do our pennies math.
Just do leftover divided by 8.
All right. So compile, run. Okay, I'm going to enter the same value. All right, so that's what we have left over. So you can kind of see why it's being turned into a 2 instead of a 3. Okay, so that's what the problem is. For now, I would say, like, if you don't want to deal with this, you can be like, you know what, it's close enough for chapter 2 work. But if you're so intent into actually making this correct, okay, what's actually happening here is the math that's happening like inside of, in here, right? Right here. Actually, really, it's just this leftover right here, right? That leftover is like all messed up right now. It's 0.2999999. And I did go over some chapter 3 methods that we can use for the math class. So you can just say like math.round, right? It'll round it for you. So now, let me see. Where should I do this at? Actually, I'm not gonna do this here in this equation because I won't be able to capture that in the variable leftover. I want to actually put it right here. Remember, math.round, or the math class, is part of the java.language package, so I don't have to import anything to use it. So now I'm going to compile, and I'm going to run. I'm going to enter my amount, $46.73. As you can see, that pennies is now 0. Dang it, what the heck did I do?
They rounded it as decimal.
Yeah, okay, I'm sorry. I totally messed that up. So you're supposed to multiply it by 100 and then round it. Yeah.
Yeah.
Okay, sorry. So we actually do need to use it right. So we're dividing it, we're getting what's left over. So right here, math.round. All right, that's where you're gonna use it. Yeah, let me just take back what I did, just pretend I never said what I did there. Just ignore that part. All right, so control 1 to compile. Control 2 and $46.73. And there you go, 3 pennies now. But it's, so we're basically turning it to an integer, but before we actually convert it to an integer, we're gonna round it. Right, so it's happening right here. In fact, I don't think we need to call math.round, or I don't think we even need to cast it, because I believe math.round already returns an integer, but let me just check that real quick. All right, let me just compile, run. Okay, no, it's upset at me. Okay, so it does return let me see, what is it telling me? Required an int, it's just treating it as a long. Okay, so it's saying that this right here is a long, and we're trying to put it into an integer. Okay, so you do need to cast that to an int. But anyways, that's one way of doing it. The other way would be multiplying everything by 100 as you divide it. That's another way to solve this problem. And I believe it should work. If it doesn't, I mean, you can do 2 things. First thing you do is just ignore it and just say, like, you know what, like, we talked about this. It's compliant with the IEEE standard 745, if that's what it was. I can't remember. Yeah, 754. Or if you really want to correct it, which I think it's actually a good programming trait to actually want to correct something that's just not correct, right? You see that problem, you're like, how can I fix this problem? I think probably the easiest thing to do is just round instead of, losing that precision. Because before I actually rounded, what's happening is I basically have 2.9999, and whenever you convert it to an integer, you're just basically removing all the decimal places, right? So it sees it as a 2.
Yeah.
Okay. Any questions on this? Yes.
When I came across this problem, I just added 0.0001.
Okay, but I guess you could do that, 0.001. It fix it for everything?
Yeah.
Okay. I mean, that's kind of like a hackish way of doing it.
Because it wasn't over to where if I had 1 cent and it counted that 1 cent, it wouldn't count it to 2. But it wasn't too low to where the 9s were affected by it.
Okay, yeah. I mean, that's one way of doing it. But I think probably the more correct way of doing it would probably be to use the math.round. But either way, like, I'm not going to take off points if you don't correct this, or you do correct it like a different way. Yeah, but I just wanted to show this. Normally I do demonstrate this, but I forgot to talk about it whenever maybe I did talk about it. I never talked about this problem.
You did.
I think I might have done it I did talk about it?
In the beginning, you
Okay.
said that Java uses decimals with the math, and sometimes it gets funky.
Okay, yeah. So I guess people or students like won't remember until they actually come across a problem.
I think you went over that there is accuracy loss, but I don't think you went over how to correct it.
Okay, but this is one way to correct it, right? We can use what we learned from chapter 3 to correct what we're doing in chapter 2. All right, any questions on this? Yes.
If this was the case, it would be important to like annotate on it.
You mean like in the homework?
Yeah, no, with anything, with coding in general, programming.
Huh. I guess it would be important, but like for things that actually require like it's like you're trying to do like some scientific calculation, or you're handling like real life money, like you wouldn't use double and float for those classes. There's actually in Java provides a class called like big decimal, right, which handles these types of situations.
But in this case, where everything is like something, and then all of a sudden it's math.round, it would be important to like, if someone goes over the program to.
Oh, you mean like a code comment or something?
Yeah. Is that what's code comment?
Yeah, actually, I mean, code comments are always important. I don't really like emphasize you doing that in Java 1, even though I guess I should. But whenever you get to Java 2, like, yeah, I make you document everything. But yeah, no, you're right. Like, because so the whole idea about code comments is you're not the only person who's going to be working on this code, right? Like, if you work for a big company or whatever, and at some point somebody else some junior person is going to come in, take over you. You're going to get promoted, right? Or maybe move to another company, and they have to maintain your code. They're going to come across this and be like, oh, why did he do math.round? Is it needed? I don't know. Maybe I should just take it out, right? But if you put like some type of comment, like, round leftover before converting to penny to prevent precision loss. Right? Something like anything would be good. But I'm not really grading you on like documenting your code just yet. But yeah, no, it's always good to think like that though. Like making, because what if you come back to this next semester and you see it and you're like, oh, why did I do that? You made a note to yourself. You see, you can explain what you did, and then you understand like, oh, this is why I took this approach. But yeah, you can document it, but I won't take off any points if you don't. Yeah. Any other questions? All right. These are all good questions. These are all good things to know, like these little quirks that kind of go around with programming. It's not just a Java thing. It's also like anything, any computer that does math in binary and converts it back to decimal are going to have similar problems. Okay. All right. So let's hop into chapter 3. You close all of this. All right. So the last time we met, I just kind of told you everything you need to know about chapter 3. So today what we're going to do is I'm going to go over the first 3 sections, and then I'll give you a quiz on chapter 3, and then we're free to go. Also, if you haven't shown me your programming 1 homework or your chapter 1 homework, you need to start doing that. Like, this is the last week that, not that I would accept it, but like I'm hoping that everybody just shows it to me this week, so that I can put your grade in and we can move on. Right now we're just focused on finishing chapter 2. So if you don't have a grade in for chapter 1, make sure you show it to me either today or next class. Okay. All right. So, first section: creating objects. A variable holds either a primitive value or a reference to an object. A class name can be used as the type to declare an object reference variable. Right. So here they're saying a string title is an object reference variable, and it's going to hold a string. No object is created with this declaration. An object reference variable holds the address of the object. The object itself must be created separately. All right, so what they're saying here is you're actually just declaring, you're telling Java, I'm going to reserve the variable title to point to an object in memory that is a string, but you're not actually creating anything just yet. Okay. The point in which an object is created is called instantiation. At that point, that's when the object is actually placed into memory. That's when you call the constructor. That's like when I'm doing the scanner class, I'll do the new scanner, and then I'll pass in the reference to the keyboard, system.in. Like that is the instantiation part of an object. All right, next section. Generally, we use the new operator to create an object. Creating an object is called instantiation. So the term instantiation is something you will see on your midterm and final. So make sure you know what that means. An object is an instance of a particular class. So here they're giving you a demonstration of how to instantiate a string. They're saying title is equal to new string, and then Java Software Solutions. Now Java does have, in fact, most programming languages have special syntax for strings because they're used so often that we don't actually have to do the full instantiation with the new operator and the constructor. We just simply pass, like just assign it to a string literal, and that's the instantiation of that string. We've seen that once an object has been instantiated, we can use the dot operator to invoke its methods. So invoke is another term that you need to know for the midterm and final. So number chars is equal to title.length. The method may return a value which can be used in an assignment expression like above. A method invocation can be thought of as an object to perform a service. Okay, so we're asking the object to perform a service. So a method invocation can be thought of as asking the object to perform a service. So we're telling the string, give me your length, and it's giving us back an integer of the number of characters inside of that string. Note that a primitive variable contains the value itself, but an object variable contains the address of the object. An object reference variable can be thought of as a pointer to the location of the object. Rather than dealing with an arbitrary address, we often depict the reference graphically. So I don't know how this is. Yeah. I kind of feel like these are bad ways to. I'm gonna go where they did, and then I'm gonna draw up my own thing to maybe understand what they're talking about a little better. Anyway, so you have num1, which is a primitive data type. It holds a value. You have name, which is an object reference variable. It points to the string Steve Jobs. The active assignment takes the copy and stores it in a variable. So for primitive types, if you have num is 38 and num2 is 96, if you say num2 is equal to num1, you have two copies of that value in memory, where for objects, you just have two reference variables that are pointing to the same object. So for object reference variables, the assignment copies the address. So name is equal to Steve Jobs, name 2 is equal to Steve Wozniak, name 2 is equal to name 1. Now they're both pointing to Steve Jobs. Okay, so that's called aliasing. Let me just try to draw something else up, which may be easier to understand. All right, so let me open this board. All right, so we have memory, okay? So memory is where we store data. We'll just say like right here is our memory. All right, and I'll just label it. All right, let me use a different color. What the heck, is this broken? All right, and like these all have like different address values. That's supposed to be an A. Okay, and like there'd just be like some weird hex value that kind of goes for each one of these locations. All right, but anyways, you have all this memory that a computer has, and whenever you're writing a program, like whenever you're writing code, you can declare like a variable, let's just say like int num1, 37, int num2, I think they said like 96. All right, anyways, so because primitive data types have a defined size, right, we know that, okay, well, 37 was gonna take up like, you know, this much memory. Okay, and you have 37 right here. And 96 is an integer, so it's gonna just take up this much memory. So inside of here you have 96, okay? So these are what we call primitive data types. They have a defined size, right? So whenever we do things like num1, actually num2 is equal to num1, the value is actually copied into that location, okay? That's 32 bits. That value now went from 96 to 37. All right, now whenever we have an object in memory, okay, let's just say like string, okay, and we'll just say like name1, and name2, we'll just say like Bob. All right, does anybody know the size of a string? Like how much memory does a string take? You guys don't remember this from when I talked about it? Okay, I never talked about it. Like we don't know how much memory an object actually takes. Okay, so like it was a trick question. All right, but I mean we could figure out like generally like how much memory this takes out, right? So we know that chars are 16-bit, right? So we know, okay, well if they're 16-bit, there's 1, 2, 3, 4, right? 4 times 16. That's how much memory it will take up. But generally, like objects, there's no like defined size of this is how much memory a string is going to take up. It's never going to get any bigger. It's never going to get any smaller. Okay, all objects are like that. There's no defined size for an object. So like an object might take up, you know, like that much memory. Okay, and like just say like that's name1, and then like name2 is like right here. Maybe it just takes up that much memory. I don't know. Like we're just kind of guessing here, right? So these object reference variables, whenever a variable holds a reference to an object, it doesn't actually like hold a specific memory size or spot, right? It just points to the address of where it starts. So string 1 is pointing there, string 2, right, or name 2 is pointing right there, right? It doesn't know like how big it is. I mean, it knows what the string is, but like a string doesn't have a defined size, so there's no way of saying like, okay, from this memory location to this memory location is the entire string object. It's just, there's where the string lives in memory, There's where the other string lives in memory, okay? So when I do the assignment, name 2 is equal to name 1, I'm not actually copying Mike, right? Over here is Mike, over here is Bob. I'm not copying Mike over here, meaning I'm not like just writing over Bob. What's actually happening is, let me see if I can erase. Can I erase? No, oh, maybe I click that. What's actually happening is the name variable is no longer pointing to Bob, it's pointing to Mike. Does that make sense? Right, so Bob's over here all by himself, no object reference variable pointing to it. So the way Java handles this is there's a process called garbage collection. I don't know what color to use for this. I'll use red. Yeah, there's a process called your garbage collector. So we'll just say like GC, like it just cycles, right, every so often. And it's gonna find objects that don't have a valid reference, and it's just gonna remove that data and free up that spot for your system. Now, other programming languages like C++, if you put an object into memory and you no longer point to that object in memory, you have to call a destructor to remove that, to free up that space in memory. All right, so I don't know if you guys heard of a memory leak, but what that actually is you're creating objects, you're putting them to your system's memory, but you're never freeing up that space when you're done with that variable. So like your memory starts filling up, and then at some point your computer will crash. That's a really big problem. Like in other programming languages, for Java, it doesn't exist as much because you have this process that is going to go through and search for invalid references and free up that memory spot. Like so, if we did this right here, Bob no longer has an object reference variable pointing to it. At some point, the garbage collector is going to cycle and see, okay, well, nothing's pointing to Bob. I'm going to go ahead and free up that memory so that the computer can use that space in memory. Okay, so that's one of the benefits of Java. Actually, is it has this memory management for you, which is kind of, a pain in some other programming languages. If you don't do it correctly, you can have a memory leak, fill up your computer's memory, and then your computer will have to be restarted. Okay, any questions on that? I mean, there's always issues with this, or at least in the past, with like computer games would just like have a memory leak and just fill up your RAM, and then you'd have to restart your computer. Yeah. Okay, so luckily for us, or at least for Java, it kind of alleviated some of that, overhead to the programmer, and it does it for us so that we don't have to do that. Okay, all right, so hopping back over here. So that's basically what they're trying to represent here with those arrows and all that, is when you have an object reference variable, you don't really know the size. You just know where it lives in memory, so you're just kind of pointing to that location in memory. An alias, that's the next thing. Where's my mouse? Alias, okay, so 2 or more references that refer to the same object are called aliases of each other. That creates an interesting situation. One object can be accessed using multiple reference variables. Aliases can be useful, but should be managed carefully. Changing an object through one reference changes it for all of its aliases, because there are really just one object. Okay, so what they're just talking about is the string is immutable. So this is kind of really a bad example, but we have name 1 and name 2 now pointing to this memory location where Mike lives. Okay, now if a string was mutable, meaning it can be changed, excuse me, if I made like a change to name 2, it would affect what name 1 sees, right? Because they're both looking at the same object, right? So that's what they mean by an alias, is you have 2 reference variables pointing to the same object. So you got to be careful, otherwise you might use one to make the change and the other reference variable will see it. Garbage collection. So when an object is no longer has a valid reference to it, it can no longer be accessed by a program. The object is useless and therefore is called garbage. Java performs automatic garbage collection periodically, returning the object's memory to the system for future use. In other programming languages, the programmer is responsible for performing the garbage collection. All right, that's what I was talking about, like in C++. Once you're done with the object, you have to call the destructor so that you release that memory and the system can use it. All right, so the next section is the string class. Because strings are so common, we don't have to use the new operator to create a string object. So we can just say like title is equal to Java Software Solutions. This is a special syntax that only works for strings. Each string literal enclosed in double quotes represents a string object. Once a string object has been created, neither its value nor its length can be changed. Therefore, we say that an object of the string class is immutable. However, several methods of the string class return new string objects that are modified versions of the original. So what they mean is, like just say I have this string Mike in memory, and I say name1 dot replace M with R. I'm not actually modifying that value in memory. What's actually happening is that method is just creating a new string object with M being replaced with R. Right? That original value does not actually change. Let me just demonstrate that really quick. I know I did it before, but I just want to do it one more time because this is one of the concepts that it's hard to grasp because, but like it's like one of those things like ask on the test and only like the smart kids get it right because they're the only ones that can explain what's going on. All right, so this is what is going on with the string. It is immutable, so what does that mean? It doesn't actually change once it's been instantiated. Okay. What the heck? How many freaking things do I have open? Oh my god. You see, is it close all? Close all but this. Close all left. And close all but this. All right. And then I'll just close this one. All right, so I'm going to make a new program. I'm going to save it. Let me see, where am I? Okay, I'm in Java 1. Am I in Java 1? Yeah, Spring, Java 1, Demos, Chapter 3. All right, I'm going to call this one, I already have a string demo, so I'm going to say string object reference demo. All right, so I'm going to say public class, the name of my class, and then public static void main string array arguments. All right, so what I'm going to do is I'm going to say string name1, I'll just say is Mike. Oops. For now, I'm just going to just do system.out.println. Wait. All right, and I'll just print out name1. All right, so I saved that. Let me open up command prompt. Okay, change directory, Dropbox. All right, then I'm going to compile. I got like string demo. Get that. Dang it. All right, let me clear my screen. I'm going to run this. All right, and I just simply print out my name. Okay, so what I'm going to do is I'm going to give an example of me replacing the M with an R. So I'm going to say replace. Wherever you see, whatever you see an M, a capital M, replace it with a capital R. Okay. But then what I'm going to do is after that, I'm going to print out whatever is contained inside of name1, and you'll see that it is unchanged. All right, so this is me replacing the M with an R. But you can still see that the actual object reference variable still points to an object that has Mike with an M, okay? So what's happening here is we're just making a new copy of a string. We're making a new string but the new string has the M replaced with an R. If I wanted to capture that, I can just make like another string object reference variable, like called name replace, and just say name1 replace M with R, and now I can just say name replace and just print out that object reference variable. Right, so I still capture that object, but it's important to understand that I didn't actually make a change to the existing name1 string, right? I just used it as a basis for creating a new one. So now when I hop over to command prompt and compile, what the heck? Okay, and run, it just looks just the same, right? Just as I did up here. Okay, so, but this time what's going on is I captured that copy of that string and I saved it into another string object reference variable. All right, so that's something you need to kind of understand for the midterm. You need to be able to explain that. All right, let me hop back to the lecture. Okay, so I'm gonna read the slide one more time because it's kind of important to understand this. Is once a string, once a string object has been created, neither its value nor its length can be changed. Therefore, we say that the object of a string class is immutable. However, several methods of the string class return new string objects that are modified versions of the original. String indexes. It is occasionally helpful to refer to a particular character within a string. It can be done by specifying the character's numeric index. The indexes begin at 0 in each string. The string hello, the character H is at index 0 and the character lowercase o is at index 4, and then they give you an example. I've done that example, but it's essentially just, if you remember from the example that I did, let me see, do I have it open still, or did I close it? I closed it. No, I have it open. All right, so, yeah, here's the example. Right, here's Michael. The M is at index 0, right? The I is at 1, 2, 3, 4, 5, 6. So the length of this string is actually 7, but we start at 0. Just something you just have to get used to in programming is that the first number in programming is always 0. All right, so the very first element in any container is normally always going to be at index 0. All right, so the first character is at index 0. If I wanted to grab that first character, I don't know if you guys remember the actual call, but there is a method called char@, right? So let's just say like this was name. Damn, that looks horrible. I had a variable called name, right? And it's pointing to Michael in memory. If I were to call name dot char@, then pass the index 0, like what would come back here would be a capital M, because that's what's at 0. All right. And that is the string section. It's pretty simple, right? There are several methods that you have to know though, and I did give them to you in the last example or the last week's demos that I did, but let me show you that section in the book. So chapter 3 and string class. Okay, so this is the section in chapter. So if you have the book, you should see this section. And these are all the methods that the book wants you to know, okay? The constructor, which I'm not gonna ask you any questions on the constructor. But you have char@, compare to, concat. Dang, I didn't talk about concat. I guess I have to talk about it. Equals ignore case, length, replace, substring, 2 lowercase, 2 uppercase. I've talked about all of those. The other ones that I threw in were like trim, and I believe that was it. Can't remember. I think trim is one of the important ones because that's actually one that is pretty useful. But let me give you an example of concat. So basically the way concat works is, let's see. So let's say I have a name 1 and a name 2. And I'd say this is Bob. Okay, and if I wanted to concatenate those two together for some reason, I can do that with the plus sign really simply, really easily. Print line. Okay. And I can just say like name 1 plus name 2. Okay. And I know, like, I don't know, there's not going to be any space between those, but that's just an example of concatenating those two together. If I were to compile, did I print that out? I did print that out. And to run, you'll see that those two names were concatenated right there. There's actually a method to do that. If I wanted to just call a method instead, I can call concat. Now, just like the replace, I'm not actually modifying name 1. It's just I'm making a new copy of a string that has name 1 and name 2 concatenated together. So if I were to call what's inside of name 1, like right after I did the concatenation, you will see that it's still Mike, because the string is immutable. Okay, and there's a concatenation and there's Mike. Okay, now it might not seem that useful to you. You're like, okay, well, what's the point of that? Well, like maybe you just want to just store like two strings together without having to print it out. Let's just say you could just have this other string here called like name 3, but for some reason for name 3 you wanted it to be whatever name 1 was with whatever name 2 is added to the end. All right, so you would just do something like this, right? And now you stored that value, name 3, and now if you wanted to see what name 3 looks like, you can just print it out like right here. Dang it, I need to compile first. Oh dang, what the heck? How did I do that? Oh, I did a control S, I guess, and I put an S there by mistake. All right, and then there's name 3, okay? I mean, that's another variable, that's another method that they want you to know from the book. Okay, so I am gonna require you to know at least these ones, right? So they're fair game for your midterm. I'm gonna ask you these on your midterm, so just kind of be prepared for that. The next section is the random class and the math class. I'm just going to read through this. I've already did some examples. The section here is actually pretty short. So I'm just going to read through this, and then I can give you guys a quiz, and you can hopefully get stuck into your long-term memory. All right, so the random and the math classes. These are actually kind of important classes, especially the math class. I feel the math class, like knowing what you can use on the math class is actually pretty useful whenever you're programming in Java. Okay, so class libraries. A class library is a collection of classes that we can use when developing programs. The Java Standard Class Library is part of the Java development environment. Its classes are not part of the Java language per se, but we rely on them heavily. Various classes we've already used, system, scanner, and string, are all part of the Java Standard Class Library. The Java Class Library is sometimes referred to as the Java API. API stands for Application Program Interface. Clusters of related classes are sometimes referred to as specific APIs. So you have the JavaFX API and the Database API. The Java API, get comfortable using the online Java API documentation. So if you just Google Java API, whatever version that you want, would say like 8. So Java API 8. And I've gone to this website a couple of times, but you can kind of look up classes that you want to know more about. Like for one is a string, right? So we know the string class lives in the java.lang package. So if you click on java.lang here, and down here are all the classes in the java.language package. If I click on string, you can learn more about the string class. Right? There's so many more methods that you can invoke on a string that we have not actually talked about. And some of them are actually pretty useful, like the trim, right? You can do things like find. You can find something in a string. Where's the find? I think you can. Can you? Maybe not. Find. Oh, dang, you can't. I thought you could. Oh, contains, that's what it's called. Okay, contains. So you can check to see if a string contains like a smaller string. It says char sequence, but you can pass in a string and it will just work the same. Okay, so you basically can search your string for another string. And it's going to return true or false if it was able to find it. Okay, there's a lot of useful methods like that in the string, in all the classes actually, but the book doesn't really like go into all of them because it's just kind of like too much to memorize for a entry-level Java class. So for the purposes of accessing them, classes in the Java API are organized into packages. These often overlap with specific APIs. So here are all the different packages. You are going to have to know some of these. So the ones that I am going to test you on is java.lang, java.util, java.text. Okay. I don't think there's any others that we're going to use. But there's also java.net and JavaFX scene shape, JavaFX scene control. But let's just kind of go over the java.language. Okay, so the java.language is automatically imported for you, and it contains classes like math, string, and system. The java.util, you have to import it. It contains classes like random and scanner. The java.text, you have to import that as well. And we haven't got to this part yet, but it contains classes like the number format and the decimal format. And also the simple date format, which I'm going to talk about. Java.util also contains useful classes like calendar and date. Yeah. And that's all I can remember. I think I don't know where local date and local date time, those are also really useful classes that are new. And I believe they might be in java.util, but I don't want to like go into that too much because I'm not going to ask you that on the midterm. All right, so but you do need to know, I should probably just put like a star by them or something. So you do need to know java.lang, java.util, and java.text. You need to know what classes are contained in those. And this is basically going to be classes that we're going to go over in chapter 3.
On the PowerPoint on Canvas, it doesn't have the java.text.
Okay. Oh, on Canvas it doesn't have FX?
The text, the java.text.
Oh, dang.
It doesn't have it on there.
Okay, that's weird. I wonder why this one has it. I must have added it. Like, are you getting that from Dropbox, or how'd you?
On the PowerPoint on Canvas.
So I uploaded the PowerPoint to Canvas. Hold on. Let me think about this. Maybe you're pulling it from, because normally I just put Dropbox links. So maybe you're pulling it from the shared content, lectures. Let me just look at this one really quick and. Yeah, I don't know. Okay, so make sure, or I'll look at it and see where that file is coming from. But java.text is something important. When we actually talk about the number format and decimal format, we're going to talk about those classes. All right. Import declaration. When you want to use a class from a package, you could use a fully qualified name like java.util.scanner, or you can import the class and then use just the class name. Okay, so import java.util.scanner. The import all classes in a particular package, you can use the wildcard, import java.util.star. Okay, so what they're talking about is, I'm going to do a demo of this so it makes sense. I'm going to come over here, I'll make a new file, and I'm going to save this one as scan scanner package demo. All right, so I'm gonna say public class, name of my class, public static void main string array arguments, and I'm gonna say scanner. Scan is equal to new scanner. Listen to the keyboard, and then I'll just say like int, or no, actually have a string for name, and I'll say something like system.out.print. Enter your name. Name is equal to scan.next line. Let's just say like system.out.print line. Your name is, and then I'll just print out your name. All right, so I'm not importing my scanner class right now, so obviously this is not going to compile. So if I try to compile this, what's called scanner package demo, it's going to tell me cannot find symbol scanner. It's like super confused, right? But I can simply fix this by just coming up here and import java.util.scanner. Okay, save that. Hop over here. Try to recompile. It does compile, and I can run. It runs, and it works all the way up. All right, so I don't necessarily have to import the class. So one of the options was to write out the full qualified name. So what that means is, oh dang, I messed it up. What that actually means, let me compile over here again. You can see that it's broken again. Okay, that means is wherever I have a scanner, I just tell Java exactly where that class is located. It's located in java.util, and I'm gonna also have to do that to the constructor. I'm gonna save that. Okay, so this is a little longer, right? I'm basically telling Java that's the full path of that class. So I'm having to put java.util.scanner, and now when I clear my screen and compile, it compiles and runs exactly the same. Right, that's another way of doing this, is by just writing out the fully qualified name. The other way of doing it is if you want to import, you can also put in a star. Now the disadvantage of writing a star is that it just is going to just import everything from java.util, but then it doesn't really give you any visibility of what actual classes that you're using inside of this file, right? So like just say you're using several classes. I'm using the calendar, the date, the scanner, all from the java.util class. If I put a star, I'm not actually giving any visibility to the developer of what classes are being used within this file. Okay, now it might be easy for us to like look at a program that's like 10, 15 lines, but in the industry, like there's files that are like 1,000, 10,000 lines of code. So if you put the full path of what it is you're trying to import, it'll be easier for somebody to look at that file up top and immediately tell what classes that you're using into that file, instead of having to like just look through the entire file. Okay, but I don't really take off points for using the wildcard, but I'm just telling you the cons of using the wildcard. So I compile, it compiles, and I run, and it runs just like it did before. There really isn't no difference than what I did. It's just I imported this class 3 different ways, right? Writing out the full name up here with the import, putting the full qualified name in front of the types, and then using the wildcard. And those are the 3 things that this slide talks about doing. All right, so let's see. All classes of the java.lang package are imported. Excuse me, dang it. Still got that stupid cough. Are imported automatically into all programs. It's as if all programs contain the following line: import java.lang.star. That is why we did not have to import system or string The scanner class, on the other hand, is part of the java.util package and therefore must be imported. The random class is also part of the java.util package. It provides methods to generate pseudo-random numbers. A random object performs complicated calculations based on a seed value to produce a stream of seemingly random numbers. They give you example. I've already done an example on this. I'm not going to go over it, but I think what the important thing to take away from this is to understand like what numbers are going to be generated. Okay, so here we have gen next int, and we're passing in 25. So remember, for the random class, whenever we're passing in a value here, that actually means the number of numbers that you want. So if we're telling it to generate random numbers, we're passing it a 25. The actual value of the range that we're going to generate is 0 through 24. Okay, because everything starts at 0. Same thing with the index, same thing with the random numbers. So you pass it 25, that's how many random numbers you want to generate. You have the range 0 through 24. This next one, we're saying we want 6 random numbers, 0 through 5, but we're offsetting it by 1. So that means we're going to get 1 through 6. Next one is 100 values. 100 values is actually 0 through 99, right? But we're offsetting it by 10, so that means we're going to start at 10, and we're going to end at 109. Yeah. Okay. Next one, we pass in 50. We want 50 random numbers, 0 through 49, and we offset it by 100. That means we're going to start at 100, and we're going to end at 149. The next one is we're asking it for 10 random numbers, so 0 through 9, but this time we're offsetting it by a negative number, which seems kind of confusing. So it's basically just 0 minus 5, which would be negative 5, and 9 minus 5, which would be 4. So the range here would be negative 5 to positive 4. The next one, we have the range of, we want 22 random numbers, so our range is 0 through 21, but we're offsetting it by 12. That means we're going to start at 12, and we're going to end at 21 plus 12, which is, I don't know, 33? Yeah, 33. Okay, and then here are all the answers that the book gave you. So, yeah, we did, it was 33, 12 to 33, negative 5 to 4, 149, right? You can see this range. So I will be testing you on understanding this on your midterm. That's why I want you to use the random class in the homework assignment and not math.random to generate your random numbers. So you can get comfortable with how to produce these ranges. Okay? All right, so now let's look at this next one. If we want a range of 0 through 12, what do we need to do? What value would we pass it to next int? 12, right? 13. I was just messing with you guys. Okay, so 13. So that gives us 0 through 12 because there's 13 numbers. Remember, the number that you pass in is the number of numbers you want. So there's actually 13 numbers because you're including 0. Okay. All right, what about the next one? Okay, so you pass in, what would you say? Or somebody said something? 20, right? And then, so if you pass in 20, you get 0 through 19, and then you offset it by 1. Like, you're just going to add a 1 to the result. And now you got 1 through 20. Okay, the next one. 15 through, so the way I like to do these is just work backwards, right? Hold on, I think I could do something cool with this thing. Hold on, let me see. Full screen. Okay, cool. Now I think I could write on this. Okay, so just think about it backwards, all right? So if you have a 15 here, that means you're going to have a next, I'll hold my screen, next int, it's not working as clean as I thought it would, plus a 15. All right, let's look at the next one. This, just by looking at negative 10, we know we have a next int minus 10. Okay, so we did part of it already. Now we just got to figure out what number goes here, what number goes here. Okay, and the way you do that is, I don't know if you guys remember the equation I gave you. It's the difference between these two plus 1. So you just say 20 minus 15. What is that? 5. And then what's 5 plus 1? Okay, we'll put a 6 there. All right. So the difference between 0 and negative 10, if you did 0 minus 10, what do you get? Negative 10. I guess this is the absolute value of that then. So you get 10 plus 1 would be 11. Okay? Let's look at what the book has. Oh, dang it. This is a picture. Sorry. Sorry. All right. We did exactly what the book did, right? We worked backwards, and it was easy for us to find what the answer is. Okay? So don't get intimidated by these. It's just simple math. Whatever's here on the, like, whatever you're going to start at is going to be what you're going to put at the very end. Is the offset 15, 15. Negative 10, negative 10. Okay, and then this value here, the 11, is simply just the absolute value of your max value minus your min value plus 1. All right, so the difference is 10 plus 1, 11. So 20 minus 15, 5 plus 1, 6. It's really simple to find these things. It's just, just remember that equation and you can get through these. All right, next one we're going to talk about is the math class. So this is another one that's actually pretty simple. Hold on, before I go on, let me look at what the book wants you to know for the random. All right, so this is what the book wants you to know. The next float will give you 0 to 1. It does not include 1, but it includes 0. But it's basically just fractions of 0 through 1, not including 1. Next int returns a number in the range of all plus values of integer. Next int with a seed value will give you the range of 0 through the number minus 1. Right, these are the methods that the book wants you to know. And now we're on the math class, so I might as well just go there now. These are the methods that the book wants you to know. Now, I'm not going to ask you questions of arc sine, or the cosine, sine, tangent, or the arc, cosine, arc, sine, arc, tangent. Okay, they're all right here, so you can kind of just forget those. Like, just pretend like, just know that they're there, but like, I'm not going to test you on your midterm. I'm not going to ask you questions about them. I'm not going to ask you questions about it on your final. But the ones I will ask you questions about is absolute value, seal, exp, which is the natural number to some power, floor, a random square root. I thought there was more than this. What the heck? Is that really it? Huh. Your book went really light on you. Okay, well, those are ones that you're going to have to know for the midterm and the final. All right, let me hop back to the lecture. Okay, the math class is part of the java.lang package. The math class contains methods that perform various mathematical functions. This includes absolute value, square root, exponentiation, trigonomic functions. The methods in the math class are static, so this is something you need to understand. You will have questions about that. The methods of the math class are static. Does anybody know what that means? What does that mean? The methods in math class are static. Okay, well, static does mean not to change. I agree with that. Anybody else have another answer? What does that mean in terms of programming? What's that? Okay, so stays the same, but what it means for us as programmers, for Java, it means that we do not need an instance of the object in order to use the methods. Okay, so whenever we want to use the scanner class, we have to instantiate a scanner object, right? That's the very first line that I do. Whenever we want to use a random, we got to instantiate a random object. But for the math class, we don't need to do that. As soon as we want to use a math method, we just say math, name of the class, dot, and then whatever it is we want to do. Okay? In fact, I did it in one of the examples already. Actually, no, it was your homework where I just rounded, right? I didn't have to like import or anything. I just said math.round. Actually, I have it up right here. Okay, I did it right here, right? And if you look up at the top, there was no, like, I did not make any math object in order to call that method. Since it's part of the java.language package, there's no import for the math either. Okay, so those are some things that you need to understand. These are types of questions that get students, is that they don't quite understand what it means to be static. It just means here's my name of my class, math, and then I'm able to invoke that method from the class name. I don't need an instance of that object. Or the scanner class, I had to instantiate the scanner object first, and then in order to use it, right, I had to use that object. So next double, I had to use my scanner object, right? And really that was it. That was the only time I used it there. But for the math, it's different. It just comes straight through the class name. All right, so methods in the math class are static methods, also called class methods. Static methods are invoked through the class name. No object of the math class is needed. So here they're giving you an example of using methods from the math class. We discussed static methods further in chapter 7, and they give you some examples. I already did some examples with the math class, so I don't need to do any. All right, any questions on anything that we talked about today? Okay, so I do want to give you a quiz to do before you go. Let me see if I have it up already though. Wait, dang it, wrong one. Has to be one of these. So it's one of my popular ones. So quiz 4, quiz 3, quiz 5. Let's see. Dang, it's none of them. What the heck? What was it asking in the other class? What quiz 2? Okay, this is what I want you to do. Except I'm going to change this. Okay. Let me edit this. Control A, Control C. Hop back over to your assignments. So the last quiz that I gave you was quiz number 3. So this is going to be quiz 4. All right, so this is what I want you to do. I want you to write a program that prompts the user for his first and last name, then create a username for the user by generating or by using the first character of the first name combined with the first 5 characters of the last name, all in lowercase. All right, so you have to use a few string methods to get this done. Then output, dang, that's really all I said. This is an easy quiz. We'll just go for that for now. Your homework actually, this is one of your questions from your homework, but your homework actually has you generate a random number between 10 and 99, and it wants you to add that random number to the end of this username that you generated. But I'll leave that out for now, so it's not too complicated, but just note that this you're doing like the very first step of programming project 3.1, I believe, or 3.2. Okay, yeah, it's really simple. Scanner class, ask for the first name, ask for the last name, then make another variable called like username, and then store the first character of the first name and the first 5 characters of the last name. You want it to be all in lowercase though, so make sure you use the method to lowercase when you're doing this somewhere, right, in order to get that username. All right, go ahead and work on that. If you have your homework that you want to show me, you should probably do that now before you start your quiz so that I can give you your grade for that.